At some point, you run into this situation where the standard tools that are provided by different companies or different build systems, such as Android Studio or Xcode I'm talking about, that at this scale, certain million lines of code, you reach a point where the IDEs can't really open the full code anymore.
Welcome to Nerd Out at Spotify, where we bring you behind the curtain of the world's most popular audio streaming subscription service. Machine learning, open source, clouds, tabs versus spaces. We'll talk to Spotify engineers about interesting tech issues, big and small. I'm Dave Zolotusky, principal engineer at Spotify. Most people think of Spotify as a mobile app, but of course, it's not just one app. There's an iOS app, an Android app, and then there's Spotify for the web and for a lot of other places, like TVs and cars. It's a lot. When you're a team of 5 or 10 or even 40 engineers, coordinating your code is easy. But when you're a company of thousands of engineers working on all these different apps all at the same time, things get much more complicated. Today, we're talking to Patrick Balestra. He's an engineer on Spotify's client platform team, and his job is to make sure that every Spotify developer has a great experience, no matter what app they're building for. Every day, he's tasked with answering questions like, what happens when the standard tooling for iOS and Android just doesn't cut it anymore? What's it like to maintain an app when there are literally thousands of commits every week? And how do you develop your feature without worrying about everybody else's feature, when at the end of the day, you're shipping a single massive app? In other words, what's it like to build at Spotify scale? Can you tell us a little about what you do at Spotify, Patrick?
Sure. I'm a staff engineer working mostly on developer experience inside the client platform tribe. So I basically spend my days building tools, workflows, systems, anything really that can help our developers and engineers be more productive and shipping code and features to our users faster.
So you said a whole bunch of things there that I want to make you dig a little bit deeper into. But one thing you touched on was client platform. You talked about client engineers. Can you kind of elaborate on what you mean when you use the word client?
Yeah. I mean, that's a pretty big range of engineers. Usually those are engineers that ship code in our client apps. Those can be, our iOS, Android apps that ship on the web as well, and really anything that users touch or on their phones or their computers or any kind of device like that.
I gotcha. So client can mean mobile, but client is really any surface on which a user can interact with Spotify. So I don't know, like TVs, speakers, web browsers, cars, whatever.
Correct. Yes. Of course, as we're very much into ubiquity, we have a lot of devices. And so we don't really have a clear definition yet of what we support exactly, but we're trying to expand ourselves into supporting more and more clients because, of course, we want to support engineers and shipping the same kind of code everywhere we have users. We have a lot of different tools that we would provide developers with. That can be, a build system, that can be releasing a specific client, that can be a simple building block into the architecture of an application. So since there are so many different building blocks and tools that we support, we have to make sure that all the tools that we provide to people are really efficient to be able to support that level of complexity that we see every day.
Okay, we've established what a client is and that there are probably tons of people at Spotify working on different clients. What does your team do for them? And kind of why does your team even really need to exist as opposed to just, every team creates their product and has a CI pipeline and has, whatever other base stuff?
Yeah, that's a good question. I work mostly on developer experience and build systems these days. So what we really try is to take the pain away from our engineers that want to focus on building great features for our users, in having to deal with build systems, in having to deal with CI, in having to deal with all kind of error messages that pop up and they don't know really how to interpret. So we try to make it easy for people to build code wherever they are. So either that's iOS, Android, web, whatever else is happening at Spotify. And it's really a matter of simplifying things for our engineers to make sure they can focus their day on writing actual code that is useful for users and we can just deal with for them.
One other thing that you said when you were introducing yourself was you said that you were a staff engineer. Tell me what that means.
Yeah, that's $1 million question, I feel like. Many people always ask that. So I feel like being a staff engineer means being able to influence multiple teams and being able to really solve problems that are maybe 2-3 years ahead of time, right? Ahead of us. So that means foreseeing what problems we're going to have in our infrastructure, in our platform, and how do we make it so that the problems that we are solving today will fit into the long-term strategy.
So what does that look like day to day? Like, what do you do?
So day to day, I help out various squads in driving forward our monorepo migration, for example, these days. I help engineers learn more about our infrastructure, our Bazel build system, for example, which has a really steep learning curve, as many people have reported. And then I help out, of course, product engineer managers and everyone else, leadership, in trying to understand exactly what we're doing and how do we go about solving certain problems for our engineers in the future.
And how long have you been at Spotify?
I've been at Spotify for 4.5 years now. Yeah.
And all of that time in the same space?
Pretty much, yes. I've been working in developer experience since I started. So I haven't really seen that many different parts of Spotify. I've been mostly stuck in client platform, which I really enjoy so far.
Cool. So then I want to hear a little bit about how client platform came to be what it is and how this developer experience space both kind of figured out that it needed to exist, but then grew to the place it is now where we're doing all of these things and have multiple staff engineers looking into all this long-term stuff. Tell me a little bit how this thing came to be.
Hearing from a few colleagues that have been here for 10 plus years, client platform was really the core of mobile development back in the days. So there used to be a single team in the beginning that did everything, wrote the app, shipped it, managed the build system, and so on. And over 10 years, of course, teams have split up and responsibilities have been shifted around. So the original team went to kind of like splitting up into platform instead and infrastructure. And the other part, which was actually the feature part, which was developers building the actual features and the UI that go into the app. And so over time, the responsibilities became more and more important and bigger. So we decided to split up into different parts. Initially, it was called App Development Productivity, which was then renamed Client Platform, which is, of course, to signal that we care about every single client that we have out there. So now these days, we are split up into 3 parts. One is the developer experience part. We have a building blocks part, which takes care of building reusable libraries for all our clients. And then we also have quality platform, which is the part that takes care of releasing the app, making sure that the quality is always on the level that we expect it to be, and making sure that we're monitoring bugs and crashes that users are experiencing in the wild and reporting them to the feature team so that they can go ahead and fix crashes and behaviors like that.
The other thing that I'm really curious about as someone that has very minimal mobile and client experience is what is it about the Spotify client applications and especially the mobile phone apps that makes us need this many teams? Kind of, you said it's a large team, it's broken up into 3 pieces, like all of this just to build this one app.
It's a question that many people ask, right? Why do we need so many teams and so many engineers? So the tricky thing about mobile apps is that at the end of the day, the application is just one single bundle. So it can consist of multiple million lines of code, hundreds of thousands of tests. And at the end of the day, or at the end of the week, which is what we do, we have to ship one single app to every store. Either that's the Google Play Store or the App Store. And so there needs to be a very big amount of synchronization and feedback on the quality of the app to make sure that we are safe to release the app. So we have almost, I think, under 50 squads every week contributing to these mobile apps. So every single squad has to sign off that their features are good to go. And so we need to have a lot of tests, a lot of people, a lot of bug reports to make sure that the quality of the app is really what we expect it to be before shipping it to the stores.
So it's really more of a human coordination effort to get this thing done on time and released regularly than it is anything about the technical chops of the app itself that make it complicated and requiring these teams? Or are there additional technical things about the app that make your team's life difficult too?
It's a very big app. So whatever goes wrong in the app is going to impact everyone else, right? We don't really have microservices like in the backend world, for example. At the end of the day, we try to have code isolated from each other in every single feature. So each team owns a separate set of features. But when you get to release or build the app locally and see it in your simulator, it's still going to be one single bundle. So effectively, you need a way to cache all the code that you're not changing, for example. So that's what we're really focusing these days, is being able to speed up the iteration speed that developers have both locally on their machine when they're building new code and new features, but also on CI when they're getting a feedback loop from all the tests that we need to run on a continuous integration system. Right. So we're really focusing on making sure that we can provide feedback to developers as soon as possible so that they can move on to the next thing and build more and more features for the users.
Tell me a little bit more about what it means to be a really large app. I think you mentioned it's a lot of code, but why does that make it so that any one thing breaks everything? Or why does that make it really difficult for the engineers? Why do they care that there are 149 other squads working on the same bundle?
It's a problem on many sides, I would say. One side you could see that it's a problem from an architectural perspective. You need to make sure that there are certain best practices that engineers are aware of to make sure that the quality of the app is always what we expect it to be. Also, don't want to, of course, duplicate efforts and copy paste code from one feature to the other. So we need to make sure that people are aware that there are a certain set of tools that they can reuse in their features to build features faster. And then at the end of the day, it's true that developers don't really care about what's going on into the app. But from one point of view, they need to be also aware of what other code are changing and it could be impacting, right? Because the app is only one. And so if you're doing something that is using a lot of CPU or memory in the app, you're going to affect every other feature that is running at the same time. So there needs to be some kind of awareness of how an app works on the phone.
Are there points in the evolution of the Spotify apps where some of these problems became more and more apparent, like times when the company really struggled? Or was this just kind of the app grew linearly, these problems grew linearly, and it was kind of a clear trajectory as opposed to like specific moments where things just fell apart because they got too big or too complicated or anything?
Yeah, I think over the years, we always saw pretty much like a linear growth. Of course, there have been times in the history where we saw a bigger growth than other years. And so at some point, you run into this situation where the standard tools that are provided by different companies or different build systems, such as Android Studio or Xcode I'm talking about, that at this scale, a certain million lines of code, you reach a point where the IDEs can't really open the full code anymore. And that's where we needed to look at alternatives, look at solutions for being able to still provide an efficient developer experience to engineers, but find different ways from what's really the default way of developing on mobile, for example, for teams that are 5-10 people instead.
So tell me a little bit more about some of those tools. I think you mentioned things like Android and Xcode Studio that I've actually heard of, and there's probably dozens more that I don't know about. But tell me a little more about some of the history we had with them, or like scenarios we got into where the app was too big for them and things that your team did to fix that, or maybe, I don't know, use a different tool or make changes to those tools?
So I've talked a bit about isolation before, where we try to isolate the code, the repo by feature, for example. So every team would be able to have their own code. For example, the now playing view. You could have a specific system that contains all the code for the now playing, and that's where you would focus and have your small sample app where you can actually iterate on your now playing code without testing the full application on your machine. So those are projects that we have used in the past to kind of try and speed up the development speed while keeping in mind that, of course, we need to ship us a full single app, but we wanted to give a different experience, a better experience to developers locally. And then we also moved on onto looking at other build systems that are very common in the industry today. For example, like Bazel. We are moving all our client code to build with Bazel these days in order to make sure we can have a remote cache that is very efficient in order to not rebuild code that has been rebuilt before. And that really speeds up experience for engineers locally.
So what's it actually like trying to change how developers are used to working and changing their tools kind of right underneath them and changing their kind of day-to-day workflow?
It's definitely a big challenge. People really talk a lot about documentation, and we try to write a lot of documentation. But at the end of the day, people don't really take the time to read documentation through. That's what I think happens every day. So we do spend quite a bit of time in making sure that people are aware of the changes, and we help them out over Slack, for example, quite a bit every day to make sure that we unblock them and we make them more productive. So that's usually how we try to drive these big changes, by teaching people, running courses, writing documentation, and writing communications for them to learn more about what's changing for their daily workflows.
And are a lot of the changes that you make things that you need to document in the sense of like things just change for our engineers and then they don't know how to do their job the next day? Or is it a lot more of like they could never change and things would still work, but that kind of goes against a new best practice? So what you really need to do is kind of nudge and influence people to change their day-to-day as opposed to like you broke everything and they need to learn a new workflow.
No, of course, we try to never break their daily workflows. So we try to keep our tools and APIs pretty stable. So it's really rare that we do change systems or entry points for people to start their job. So even the switch to Bazel is pretty transparent. So people are used to running their same task. They're using to use the same IDE, pressing the same buttons, but under the hood, everything should be much faster than before. We try to give people quite some flexibility because, of course, every engineer has different needs. They work on different modules, and so they might have different customizations that they need to do in their code base. So we try to keep things pretty flexible. And so those are the few times where things really break, and then people have to relearn some different part of their workflow.
I got you. So tell me about that a little bit. What we're using before Bazel and why did we have to get away from it?
We have pretty much a different build system on every platform, right? We use whatever the platform vendor provides. So for example, on iOS, we use Xcode, which is provided by Apple. On Android, we use Android Studio and Gradle. And then we also have a big C+ library in there we use CMake. So the problems that we saw is that developers that need to contribute to all three platforms, for example, they need to learn three different build systems. They need to learn three different IDEs probably. And so we saw opportunities for aligning all of these code bases and aligning the developer experience into a single build system. And there we chose Bazel, which is a build system open source by Google and used by many other tech companies.
Tell me about the isolation pieces. You've talked about isolation a few times. I got the part about it kind of isolating teams from each other so they don't break each other's things, but how does it make the experience better? How does it tie into this Bazel stuff?
So Bazel really helps in making sure that you only rebuild what's needed. Right. So it's really, really good at finding the inputs to every single action that builds the app and reusing the outputs that have been computed in the past already. So by making sure that we can split up our code base into multiple modules that are independent from each other, we can better use this feature of Bazel where we're able to build only what's changed exactly since the developers has made some changes to the code base. So you're changing the now playing feature, for example. What we're doing is that if the now playing feature is isolated in such a way that we can only rebuild its implementation module, the feedback loop is going to be much faster. If everyone instead dependent on the implementation module of the now playing, then we would need to rebuild a lot more modules than we actually needed to. And so the experience would be much slower than before.
So a lot of the Bazel side of isolation is really around performance of build and not rebuilding artifacts that have already been built.
Exactly. It's about isolating pieces of the dependency graph to make sure that we can only rebuild parts of like smaller sets of the dependency graph.
And what kind of impact have we seen from that? How slow are the builds when building everything versus how fast are the builds when just building some isolated piece like what you were describing?
I think in the past, clean builds for some of the client apps, like mobile specifically, which is what I'm more familiar with, could go up to 20, 30 minutes if you needed to rebuild certain modules. And nowadays, if you're building a more isolated module, we can get feedback to engineers in 20, 30 seconds.
That's pretty drastic. And then what about some of the actual kind of day-to-day developer experience, like the inner loop on the machine type stuff? You talked about some of the IDs, like Xcode, Android Studio, et cetera. What sort of impact have we seen there from some of the work that you guys are doing?
Xcode and Android Studio are really good tools, but what we saw as well is that it takes quite a long time when you run into bugs to fix them, right? You have to either report them to Google or to Apple, and that usually takes some time to get feedback on those issues. So what we tried is, of course, to keep those tools, but use Bazel behind the system. So instead of using whatever system they are configured to use, such as Gradle or Xcode, we replace those build systems with Bazel to be able to better control and have more flexibility and more customizations on our side on those build systems. So we can better control and gather metrics analytics. So we had to build a certain custom systems to also collect metrics from our engineers in order to really look at what were the problems that people were experiencing locally and then address them with future updates.
So does that really mean that we're using the IDEs more for the actual development environment, the almost kind of text editing pieces, but
Correct.
It then becomes a front on top of Bazel for all the CI work and the build and all of that. So we're not using the actual IDEs for those parts.
Yeah, that's pretty much it. Many other companies do similar things with, for example, Visual Studio Code. But of course, then as you move further away from what the platform vendor recommends, which is, of course, Xcode and Android Studio, then the more and more tooling that you have to build yourself.
That's a really interesting point, and that suggests that kind of you've taken on rebuilding large chunks of what exists in something like Xcode or Android Studio within your team.
So there is a great open source community around all these tools. A lot of the companies of our size are contributing to tools in the open. So Bazel is a completely open source build system. A lot of the rule sets and plugins around these IDEs are also open source. So thankfully, we are not doing this alone, but we have a lot of great other companies that we can rely on.
Is there a lot that we're contributing as well?
Yeah, for sure. We have contributed quite a bit to various projects, Rules Kotlin, Rules at Scott Proj. We're also maintainers of Rules Apple and Rules Swift, which are community-maintained rules for building on Apple platforms with Bazel.
I think you've used the word rule in some form or another, rule set or rules or whatever, maybe a dozen times in the past minute. What are rules? Why is everything a rule?
Correct. So the idea behind the Bazel ecosystem is that Bazel is the core build system, which lives, of course, on GitHub. And then there are certain separate repos, which are called rule sets. And those are specific rules that integrate with different compilers or languages. So there are, of course, rule sets for every single major programming language. That can be Java, Kotlin, Swift, Go, even, for example. And so as a consumer of the build system, you can then integrate whichever rule set you want. And this is where Bazel is really good at. It's really good as a platform and as a language agnostic build system. So you're able to build for any platform and for any language with basically the same syntax and same concepts.
So to some extent, like rule is Bazel's way of plugging in functionality to do some additional thing. And a lot of the places that Spotify is active in and the open source communities are around the mobile, like iOS, Android rule sets for Bazel.
Correct.
One other thing that I think you mentioned, you talked about some work you're doing now around monorepos. What does that even mean in this case? Because I figure with these mobile apps, they're already in a single repo. Like you said, it's a single giant code base that gets shipped as a bundle. So isn't that already a monorepo?
Yes, we already have multiple monorepos, but we actually want to move to a single monorepo. So as I said before, we have various clients and we also have a C++ big library that contains a lot of the shared code for, streaming audio files for, logging in and things like that. So what we want to do, what actually are the problems today is that all of these code bases live in different repos. So whenever an API changes in one repo, it breaks in the consumers. So someone that breaks an API has to take care of 3 different repos that are using that API and go into all the repos and fix the consumers of that API. So the idea behind having a monorepo is that we can make these big changes into one single commit as an atomic commit. So you're able to effectively change an API and immediately get feedback in one single pull request if your API has broken a specific consumer, such as the iOS, Android, or the desktop app. And so this would really speed up a lot of the changes that developers do today because you're effectively able to see it live in one single repository if your change is doing exactly what you set it out to do.
So then tell me a little bit more about the history of this, how we got to having what you called multiple monorepos, which is a thing that I have a hard time wrapping my head around, given what I assume a monorepo means, but then to moving to where we are now.
Yeah, so today, well, I think in the past we used to have one monorepo, but then we went into having multiple repos. So now, in one way, we're going all the way back to having a monorepo yet again. So the way these repos integrate today is via Git submodules, which are not the most pleasant tool to work with. And so they're really hard for people to figure out, and they mess up really easily. And of course, there are other ways to integrate multiple repos, but it makes it so that we would have to build quite a bit of tooling around syncing these repos together and bumping dependency into each other. And so since this is done, many, many times a day by many, many developers, we of course want to streamline that process as much as possible. And so this is why we set out to have a monorepo.
So what does the process for that look like? I mean, it's just move a bunch of code into all the same repo and tell everyone to git pull?
I wish it was that easy, yeah. There are many steps that we have taken over the last few years to be able to get to a point where we have all the code in one single repo building with the same build system. And so we set out to have a list of requirements that every repo has to fulfill before being able to move to the monorepo. So right now we're in the middle of moving off our legacy build systems, which are Gradle and Xcode, and fully onto Bazel. And that will then allow us to basically remove a lot of the legacy infra and platform tooling that we have that we had to write to maintain 2 build systems at the same time until we were actually ready to move off the legacy one and fully onto Bazel. So that is the first part in doing this move. And then once every single consumer is building with Bazel and is efficient enough to be able to move to the monorepo, then slowly we're going to move one consumer at a time to the monorepo and hopefully improve the developer experience over time.
I see. And so I think at the beginning you said something about requirements to move, and towards the end you mentioned building with Bazel. Is it really just everyone's got to build with Bazel and they can move in? What are the other sorts of things you're requiring off of all of the repos before they can get combined?
Yeah, building with Bazel is the big important requirement because that allows us to really step up our developer experience. So Bazel has very nice features such as Bazel querying and diffing. So we're able to effectively know based on a single diff, what do we need to rerun? How many tests can we avoid? So effectively, compared to what we would do before, which was running 50,000 tests on every single diff, now we would be much smarter in being able to say, if this diff only changes certain modules, only rerun the tests for those modules. So this is why Bazel is the big requirement that we have, because as a monorepo, there would be a lot of code. And so we need to make sure that the moves into the monorepo has a nice experience and it does not get worse as more and more code moves into the monorepo. And then we also have requirements, of course, around isolation, as I said before. So isolation, it's really important because even if you have an efficient build system, but you rebuild everything all the time because everything depends on everything, that's really not a nice experience. And really, there is no way around that, even with a very efficient build system. So you need to have a nice and structured architecture in order to really get the best of this build system.
Yeah. So tell me a little bit more about that. How do you define or test for isolation? How do you say, yes, you have isolation versus no, you don't?
Yeah, it's a great topic. And we have many great data engineers and data scientists that really look into this. So they gave a talk this year about how we use Bazel metrics to drive improvements to the dependency graphs. So we try to collect a lot of information out of our dependency graphs, and then we display them with various dashboards to all the engineers and make sure that they understand of their changes. So a module that depends on 50,000 other modules, it's not a really great experience. And so it should be addressed. So we make sure that people are aware by telling them exactly how their experience is going to be impacted by other modules that are not really fitting the requirements that we set out to.
Yeah. So in that sense, isolation is largely about not having lots of or very complicated dependency trees. Is that like a valid summary of what you said?
Yeah, I think it's a great summary. I think also the fact that many languages today possibly don't expect or require you to list out the dependencies, that's a big problem, right? Because as a build system, you want to know exactly what depends on what to be able to not rebuild what has not changed. So we make sure that all the dependencies are declared, and they're declared in a good and structured way to be able to then drive even more improvements by splitting up large modules that change very often into smaller modules that would change less often, so that the cache would also be warmer for developers to reuse.
Yeah, that part makes sense. I think the piece about isolation, meaning having complicated dependencies, that I was struggling with was kind of, if I depend on 100 things, then a change to my module would still only mean that I have to rebuild my one module. I would just pull in the cached versions of those 100 things. So Why is it a problem for me to depend on 100 things?
It's a problem for other 100 modules to depend on your module as well. So if your module will change, then everyone else that uses your module will also need to rebuild. So those big dependency graphs are requiring the build system to retest everything that depends on your module. That's where then the build times will really spike.
I see. So my problem is that I'm looking at upside down. It's fine if my module depends on 100 modules, but it's not fine if 100 modules depend on mine.
Yes.
So then what do we do for like critical common modules? I don't know. I imagine we have like some common UI frameworks or some common communications frameworks, or like an encryption library that everyone uses across the app. I imagine that by definition has to have huge amounts of dependencies.
Yes, we try to usually split them up into multiple smaller modules so that we can limit the impact area of those changes. And also, we kind of enforce having an API and implementation defined. So we enforce developers to really be clear on what their API is, which is the public interface for their modules, and what their implementation looks like. So that the implementation is completely private. So when they iterate on the implementation, really only that module will need to be rebuilt, because nobody can actually depend on their private implementation. Of course, whenever an API changes that is very widely used, that will always be some kind of problem. So there we have other strategies such as remote execution to be able to kind of offset the long build times that such a big invalidation in the dependency graph causes.
The other thing I really wanted to ask you about was, I know the Spotify mobile app has existed for a while, and there have been some pretty major technology shifts. And I'm not an expert in mobile. The big one I know of is things like language changes. Like I believe Android went from Java to Kotlin and iOS went from Objective-C to Swift, but I imagine there are many more. How does Spotify handle with large apps like ours and all the things you talked about, like these major shifts in the ecosystem?
Yeah, we moved our iOS mobile app to use Swift. That was actually one of my first projects when I joined Spotify back in 2018. So that was a big effort because we needed to make sure that such a new language, or less mature programming language, would fit in with the quality that we expected for our apps. So we started to slowly roll out Swift to be able to have a few features being written in Swift and then monitoring the crashes and monitoring the quality. And so step by step over time, nowadays we only allow Swift to be the main programming language that developers write. Similar story with Kotlin as well. So these are very big efforts because, as I said before, there are 150 squads that contribute to the app. So everyone wants to be the first one to write a new cool feature in Swift or Kotlin. And so we needed to make sure that we have a lot of lint and formatting to also make sure that people would follow the best practices that we envision for these programming languages to be used in such big apps.
And so does that mean that over the time while you were working on these projects, we've actually rebuilt the entire apps in a new language, or what does that look like?
No, we did not do that. We took it step by step. So we continued to ship features to our users because, of course, we didn't want to stop development for a couple of months while we would rewrite the whole app, since we saw that as a pretty big risk for us to do. So we decided to take it step by step and allow certain new features to be written in Swift. And over time, as we gain more and more confidence, we, of course, made it mandatory to write all new code in Swift as soon as we saw it that it was stable enough for us to use full time.
I see. So a lot of, I don't know what to say, like foundational or maybe older features or things today are probably still shipping in Objective-C.
Correct.
But everything new we've been writing for, I don't know, months, years, is all Swift. Years.
Yeah, so that's one of the problems that we see today, is that we still have quite some Objective-C, quite some Java, that of course is at some point going to need to go away and be rewritten into the modern language. So that's something that we will definitely need to evaluate more at some point, as we see more and more APIs coming from Google and Apple also requiring and being Swift or Kotlin only, such as Swift UI and Jetpack Compose. All those technologies will only work with newer languages. So it's something that we need to keep an eye on.
Yeah, I was going to ask, because you said that's a problem that we still have this code. And it seems like it's kind of fine, it works. But it's a problem really just because Google and Apple are starting to phase out support. And we're seeing, with every next iteration of the operating systems, we're seeing issues with that code, or...
I would say it's pretty stable, but of course it limits us in the new features or APIs that we can use coming from new operating systems, for example. So at some point, we will definitely need to make a plan on how we're going to move forward in our code bases with these languages.
Another thing I wanted to touch on is, I know you talked about the kind of 30-ish minute build times we had for building the full apps, and we've done a bunch of work to isolate things so people maybe on their own machines or as part of their day-to-day developer experience don't need to rebuild the whole app. But we still have, I assume, plenty of times we need to build the whole app, like in CI systems or to create nightly builds or master builds or things like that. What sort of work are we doing there to not have that kind of exponentially grow and just make it so that, I don't know, our nightly builds become weekly builds or something like that?
Yeah, one of the things that we have with Bazel is a remote cache. We also used to have that with other build systems in the past. But with Bazel, it's a lot more efficient. So we're able to exactly reuse past artifacts and outputs that have been built by not rebuilding them again. And in the case where we have really big rebuilds, so for example, a big dependency changes or something like that, we started using remote execution, which is a really powerful concept in Bazel where you're effectively able to offload the computation of certain tasks to cloud machines. So instead of using your own local machine that has 10 cores, you would be able to parallelize a bunch of actions that you need to perform to a cluster of machines that could be in the order of like even thousands of cores. So in that way, we're able to reduce build times from 30 minutes to 3 or 2 even minutes in some cases by parallelizing the work into multiple machines in the cloud.
Oh, I see. That's very cool. And I think I initially was thinking of this in the sense of needing to do like a global rebuild for something more or less automated. But it sounds like this is something that you could do even if you're making a local change for something that has a lot of dependencies, like we talked about before. I can kick it off on my machine, but depend on some significant amount of cloud capacity to do a lot of the work.
Correct.
I see. That's very cool. It sounds like a huge amount of these problems and need for all of these like really interesting, innovative solutions is because of the size of the app and the kind of complexity of the amount of teams working on it. Why don't we just have a smaller app?
I wish we had a smaller app. My job would be much easier for sure. I think we, of course, want to experiment a lot. There are so many things that we want to do for our users. And so it's just a natural growth of any product to reach that point where so many things need to be done and so many things need to be improved, such that you have thousands and thousands of commits and changes every week.
I think that makes sense. So it's really just kind of the product keeps growing, the product keeps becoming more complicated, and that inevitably comes out in the app as well.
Yeah.
And I guess personally, do you find this kind of giant complex app and all of these crazy problems you're into fun and exciting? Or do you every once in a while really wish that this was just like a quick and simple little thing that we could put together in a weekend and didn't have all these crazy problems?
No, I think it's really great to be able to collaborate with so many people and so many engineers that are working on very different parts of the code base. So I used to scroll through every single pull request that people would open in the morning to be aware of what was going on. And if something broke, I exactly knew who to contact and who to reach out to. That is pretty difficult to do these days, but I still feel like it's really nice to see all the cool stuff that people are building in the apps.
Yeah, that sounds like a crazy, super randomized way to start every day. And how much time do you spend kind of speaking with other disciplines and other companies? Do you have a feel for what companies kind of similar to Spotify do and how unique your team is versus like there being a team like yours at a dozen companies that you're close with and meet with regularly and knowledge share?
Yeah, it's definitely one of the best parts of my job to be able to get some insights on what other companies do. We talk a lot with other companies such as Uber, Lyft, and so on to be able to really share knowledge. At the end of the day, we all share the same problems. We have, big code bases, a lot of developers. How do we make it that it's not really painful to work on this application? So we share a lot of knowledge. We contribute to different projects in the open source community. And so we all get some gains out of it.
That sounds really good. I think I want to say a year or two ago, you guys tried to get together and put together like a small open source foundation for a lot of the code you've been creating. How's that been going? And tell us a little bit about that effort.
Yeah, that's been going great. It's called the Mobile Native Foundation. So we're also members of the steering committee. And so the Mobile Native Foundation has started as a place for companies to share knowledge and kind of like start hosting some projects that are really fundamental to the mobile community. And so we have taken over some projects, gave them a new home in our GitHub organization. And so we have various opportunities for people to contribute to this project, but also we recently ran, for example, a industry survey to be able to tell people and let them know what are the latest trends in the mobile space so that people are aware of exactly what technologies are being used and how they're being used, and they can make more informed decisions in their projects.
I see. So tell me a little bit more about that. First, maybe tell me some of the projects that are owned by the foundation, the things that, whether it's Spotify or other companies have donated that have kind of been impactful there. And then I want to hear about this survey and the trends you've learned.
Yeah, we have donated one project recently, which is called Xilog Parser. It's a tool that started really at Spotify because we wanted to get more insights on what our iOS engineers were doing. So the tool basically parses activity logs, files that are produced by Xcode on every build. So we would upload this activity logs file to our servers, and then we would parse them to understand what the build times were, what the build times for every single target or every single file in the project were. And in that way, we were able to drive improvements to our build times and to our productivity. So we open sourced this under our Spotify organization. And then as the project quickly grew more and more popular, we decided to donate it to the Mobile Native Foundation to other companies contribute and maintain it as well together with us.
I gotcha. And are you seeing other companies do any of those things, like either contribute or co-maintain it, or even at least using it and getting some of the insights about their engineers?
Yeah, for sure. We received some contributions, and we know of quite a few companies using it internally to be able to solve exactly the problem that we saw in the beginning, which is getting more insights into what developers do and the performance of their builds.
I see. That's really cool. That's like a kind of an awesome, happy open source story. So tell me a little bit more about the survey you mentioned. You mentioned that the foundation does some surveys to map out trends in the space. Are there any kind of interesting insights from that?
Yeah, we saw some interesting insights for sure. A lot of the companies work in very similar ways. They all mostly use the de facto provided tools by the vendors, which is Android Studio and Xcode and the Gradle and the Xcode build systems. But there are some interesting points that we learned there. For example, in terms of A/B testing frameworks, a lot of the companies have custom A/B testing frameworks, really because there isn't a really great open source or service that allows teams to really drive A/B testing in their mobile application. So that was a really big surprise for me.
I gotcha. And what do you see like people kind of swarming on things like that to figure out how to fill that gap?
Yeah, I think it's definitely something that could be filled by either a project or a company that would be able to really help out mobile companies that need to have a solution for this kind of problem, but they don't really have the resources or the skills to build it themselves.
Yep. So then the flip side of talking to other companies, from a mobile point of view, you talked a little bit earlier about how it's kind of different from some other disciplines. And there are some places where you said it's kind of maybe a little bit more advanced or maybe a little bit, I don't know, I hesitantly use the word behind, but like doesn't have some of the same advantages. Can you tell me a little bit about how your team might interact with teams for other disciplines to kind of learn and try to improve both developer experiences through learning from each other?
I mean, if you look at the mobile space, for example, it's not more than, 15, 20 years old. So compared to other disciplines, it's really new. So there are, of course, other companies that have been working at a different scale already for a couple of years. So for us, it's really useful to see what problems they run into and what problems they solved and how, so that we can get learnings to better set out ourselves not to run into the same challenges in the next couple of years.
Yeah. And are there aspects of like engineering disciplines, I don't know, like backend or data science or things that have existed, or even web, I guess, that have in some ways to exist longer than that you're chasing features or functionality or piece of the developer experience? Like I know you mentioned isolation earlier as kind of modeled a little bit after microservices in the backend space. Are there other things you're looking to now that isolation maybe isn't solved, but is fairly well understood as a goal?
Yeah, one example that I think about is, for example, a hot reload in React, right, in the web space. That's definitely something that is slowly coming into the mobile space with Swift UI and Jetpack Compose, where you really want to give developers that fast iteration speed by giving them an immediate reaction on what the UI that they're writing looks like, for example. So this is definitely something that we're investing in and providing to our developers.
Cool. And that's something that exists today in Swift UI. So we're just trying to provide it to the rest of Spotify, or we're really kind of pushing to make hot reloading actually work?
We're trying to make it work in big code bases, which is really something that is quite challenging. So we're trying to set up our project into more and more modules that are able to efficiently display instantaneous previews for developers.
That sounds like a really great thing to have for a UI point of view. It's been a lot of fun. Thanks for coming to chat.
Yeah, thanks to you.
What else do you nerd out about?
I really like electronic music a lot, so I've been buying a DJ deck and trying to learn how to DJ. It sounds very weird for someone working at a music company, but I never really made any songs or learned how to DJ, so this is something that I'm setting out for learning this year.
I gotcha. So you're going to try to do some shows for us from home once you get it all set up?
I could try. Yeah, I could give it a try.
I'll be on the lookout for an invite sometime. Thanks for listening. Make sure to rate us and hit that follow button so you don't miss the next episode. And now, you can also send us questions at nerdout@spotify.com. Nerd Out at Spotify is produced by Spotify's Ted Vergakis and by Seaplane Armada, who wrote our monumental theme song. I'm Dave Zolotusky. Thanks for nerding out with us.